Good morning, good afternoon, good evening. This is Professor Fleming again here with the fourth in a 7-part series on perspectives on energy and environment for the course Principles and Methodologies for Sustainable Design. And this particular set of lectures, we're going to look at renewable energy from flows. And I think that's a really important part of the story here is I don't get into that. Natural resources exist in 3 forms: renewable stocks, forests, foods, water. We covered that in the first part of the lectures for this week. Some worry that the renewable stocks cannot be replenished fast enough to meet the growing demand. We also looked at non-renewable stocks such as fossil fuels, uranium, and other resources. And some worry that even with technological advancement, we could run out given population growth and the increase in affluence. Today we're going to be looking at flows: wind, solar radiation, rivers, those things that are relatively perpetual in motion. Some worry that the cost to deploy these flow energies are too high and it's happening too slow for the consideration of a sustainable future. But this lecture we're going to look at flows in more detail. Just to give a little example, and I find this chart to be very optimistic. If you look at the large green pie slice there, we're looking at renewable energy at 19% of the world's total energy, with nuclear at 2.8, the rest being fossil. That number is rising dramatically every year, and I need to get a chart in here for that. But if you look at what's going on there, there's a lot of different kinds of renewable energies are at work. I'm going to be covering most of these today, and let's go further in, shall we? One of the charts that I like is just sort of showing how many kinds of renewables are and how big they are. And you'll see that geothermal, for example, and this is not geoexchange, I'll get into the differences, very small band of power compared to the larger band of power. This yellow here is all of solar. So just to give you a sense of the potential of solar power on the planet is really dramatic. Offshore wind, pretty lucrative, pretty promising. We've got hydropower, actually relatively small, and this is the available amount of power available, or sort of a power budget. We look at ocean tidal, lots of power available there if we could learn how to harness it. And we look at wind on land, relatively small compared to other power sources. And we look at concentrated solar thermal, which I will be talking about today, has a lot of potential to create a lot of energy. And finally, solar photovoltaic, which we think of solar panels, actually has a lot of potential to provide a lot of energy for the planet. So let's go forward and look at this in a little bit more detail. We're going to start off with hydropower as our first renewable energy, or energy from flows. And hydropower is going to be section 4.3.2. Let's get into it. Let's talk about some basic facts. The units, like nuclear, are in megawatts. These dams, these hydropower stations, produce a lot of energy. The units are megawatt hours as compared to, say, a light bulb, which would be kilowatt hours. Still doing research on the efficiency. Very expensive to build, and profits are available. This is also a highly regulated industry, and just like nuclear. Externalities: ecosystem damage, methane emissions, biodiversity impacts, and actually there also is the potential for the dam to breach, causing widespread depth. So there's some serious externalities to deal with here. We think of hydro as very benign, but in fact, as we get into this, you'll see that it has its own set of impacts. Just some general facts. The power, of course, availability depends on altitude, which is gravity, and the amount of rainfall. So obviously if you're out in the middle of the desert, you're not going to see hydro as part of your normal energy potential. So mountain regions, we can do 0.2 watts per meter squared in terms of space. And this is a pretty optimistic idea that space is pretty much unoccupied, which we'll see later that really isn't going to be the truth. The experience of hydro, quality of life impacts, amazing. The amount of comfort and convenience generated for millions of people through a hydro plant cannot be denied, and has to be balanced against some of the other aspects of hydro. Sensory impacts. Well, dams can be beautiful, I suppose, and they did, though, at one time replace beautiful natural locations and also created gigantic lakes that were not there before. Now, those lakes are used for human recreation in many cases. In other cases, they're just flooded to create the pressure that's needed to build a dam. Looking at the systems of a dam, it's actually pretty simple. Step 1, you've got a vertical flow of a lot of water. Step 2, you've got water, then the rest of the water diverted into a turbine. So the water is spinning a turbine, which is linked to a generator. Step 4, and that energy is then sent out to the grid. actually pretty simple and elegant system if you think about it. So these are just the steps that I should have been showing you. Pretty simple system. It does rely though on a water cycle that's consistent in the natural world, and we know through climate change that some areas are receiving far less rainfall and some other areas are receiving far more rainfall. How that will affect energy in the future and hydropower in particular, it's unknown right now. Some of the systems that go along with hydropower, some of the details, I would say that this is a centralized system with all of the information and power located in one central location. Dam projects are extremely complex to build and have an intense infrastructure that goes along with them. They take years and years to build and billions of dollars to complete. I would say that a dam hydro is still an open loop system. One, because of methane emissions that come from the bottom of the lakes that were flooded, and some of the ecosystems impacts can be quite high depending on how large an area is flooded and how valuable those ecosystem services are to human beings. But certainly has a huge impact on biodiversity and local natural systems. And the reliability is very reliable, although subject to droughts, as we discussed before, and certainly subject to breach. Although we haven't had a major breach in decades. We had one in China where in the 1930s where 230,000 people were killed. So there is the potential of hydropower to fail, just like nuclear power, at a very large scale. In looking at the cultural and societal benefits and or costs, hydro has obviously a lot of benefits. It would be considered an energy source from the information age. Tremendous benefits for millions of people, not all though. And certainly when we get into the local peoples, and in this case usually indigenous peoples that have low amounts of power in the national governments, we look at a question of equity, a question of social equity, of how the dam might impact those. And I do see spelling error there, I apologize for that. In many cases, entire towns and villages are destroyed or flooded in order to create the lakes behind the dams that are large enough to have the kind of energy output that you need. So there is a very deep ethical question here that needs to be answered when considering hydro. And the question could be, do the needs of the many, and the many tend to be far away from where these are built, outweigh the needs of the few who tend to be local? And we see this over and over again with different kinds of energy sources. And just if you wanted to go in a little bit deeper, and this link will be posted on the course sites, there is a great 7-minute movie that goes into the details of a place called Belo Monte Dam down in Brazil, which is going to have and is already having a tremendously negative impact on the ecosystems in the Brazilian rainforest. And so I suggest that you watch that movie and gain a deeper understanding of the impact of these energy projects. So hydropower in summation, dams have led to unprecedented improvement in comfort and convenience for millions. Quality of life is up. And certainly they've created some recreational areas for human use. From a human perspective, probably very valuable. When we get to the systems, we'll see that there are some real problems. We do know that the aesthetics of natural areas of the planet have been destroyed. San Francisco, they built a dam outside of San Francisco in the Yosemite Mountain area, which was quite controversial and radically changed the aesthetic quality of that area of the country. Generates millions of valuable kWhs. Very, very expensive to build. So high risk, high reward. Low externalities compared to fossil fuels or even nuclear. So as we go up or down the chain of desirable types of energy, this might beat out nuclear. It depends on how your ethical foundations are developed. A consistent energy source as long as climate holds up. And the risk of drought, and we see this in the west of the U.S., the Colorado River is overdammed. And there are risks there of loss of power due to loss of water. From a culture and society perspective, this is an older energy technology from the 20th century. Huge societal benefits for many, huge losses in a local sense for many. And from a systems, you might say this is a closed loop system with minor externalities compared to fossil fuels. I know it's hard to say out loud, but relatively speaking, pretty small. extremely complex infrastructure to build, and extremely damaging to local ecosystems. Probably not a big impact on global ecosystems, although that could also be debated. Okay, thank you.